Let's solve the questions one by one. Number 1. Find the value of x for which 2 brackets 3 raised to power s minus 1 is equals to 162. So to find s here, the first step, you have to divide through by 2 to clear that coefficient. Divide both sides by 2. So this will becomes 3 raised to power s minus 1 divided by 2. So we are dividing both sides by 2. 162 divided by 2. So 2 will cancel out. It remains 3 raised to power s minus 1 is equals to 162 divided by 2. That is 81. So now from this part, you have to change this to its index form. So remember I said you can change the number to its index form. You use your LCM format, as in this. So we have 81. So this lowest number that can go 3. 3 in 81, 27. 3 again, 3 in 27, 9. 3 in 9, 3. Then 3 again, 3 in 3, 1. So how many 3 is this? 1, 2, 3, 4. That means 3 times 3 times 3 times 3 is equals to 81. So that is 3 raised to power 4. So 3 in 4 places. If you don't know how to find the index form, so you will be using that format. So the LCM format. So now this is the same thing as 3 raised to power 3 raised to power s minus 1 is equals to 3 raised to power 4. So 3 will cancel out 3. So this will becomes s minus 1 is equals to 4. So the base are the same. The power must be equal. So s minus 1 is equals to 4. Then s is equals to 4 plus 1. So s is equals to 5. So that's the answer. So if s is 5, you can confirm your answer. So 2 times 81 will give you 162. So answer is 5. None of the above. So none of these options. Everything is wrong. So let's see number 2. So take note, the answer is 5, as you can see the workings. So now let's see number 2. So number 2. So number 2. Calculate the logarithm to base 9 of 3 raised to power minus 4 times 9 square times 81 raised to power minus 1. So how can we find this logarithm to base 9? So we are going to use indices to split this first. So this is the same thing as log to base 9, 3 raised to power minus 4 times 9 is 3 square. That is the index form of 9 is 3 raised to power 2. That is 3 times 3, 9. So we have done 81 now, and that is 3 raised to power 4. So raised to power minus 1. So 81, the index form is 3 raised to power 4. So now this becomes log 2 base 9, 3 raised to power minus 4 times 3 raised to power 4 times 3 raised to power minus 4. So that is 2 times 2, 4. 4 times minus 1, minus 4. So now the base are equal. So law of indices, you take 1, then you add all the powers. So this will be 3 raised to power minus 4 plus 4 minus 4. That is, take 1 out of this base, then add the powers. So that is law of indices. So this will becomes log 2 base 9. 3 raised to power minus 4 plus 4 is 0. So 3 raised to power minus 4. As in minus 4 plus 4 is 0. So it remains minus 4. So I have log 2 base 9. 3 raised to power minus 4. So the base can also be 3 square, as in this base is 3 square. That is 9. Remember, 3 times 3 is 9. Then raised to power minus 4. Now this power, according to this law, log a raised to power n base b raised to power m. So this power will come back over the other power, then log a base b. So that is what we are going to use here. So this will give us minus 4 divided by 2 log 3 to base 3. Minus 4 divided by 2 minus 2 times 1, because log of the same base is 1. So log 3 base 3 is 1. So minus 2 times 1 is minus 2. So that is the answer to the question. So, or if you change everything to in form of 9, anyhow, anyone is allowed. If you change the question, remember the question is log 2 base 9, 3 raised to power minus 4 times 9 square times 81 raised to power minus 1. So since the base is 9, I can work everything through to be 9. So this is the same thing as 3 square raised to power minus 2. If you look at 3 square is 9. So because 2 times 2 will be 4. So that means 3 square raised to power minus 2 is 3 raised to power minus 4. Then times 9 square. I'll leave it as 9. Then 81 is 9 square raised to power minus 1, because 9 times 9 is 81. So this is log 2 base 9. 9 raised to power minus 2 times 9 raised to power 2 times 9 raised to power minus 2, because 2 times minus 1 is minus 2. So now everything is now in log 9. So base 9, so take 1 out of the 9 and add the powers. Minus 2 plus 2 minus 2. That is minus 2 plus 2 minus 2. So minus 2 plus 2 is 0. So this will cancel out. So it will remain 9 raised to power minus 2. So what I will have is log 2 base 9. 9 raised to power minus 2. So now bring that minus 2 to the back. So that will be minus 2 log 9 to base 9. That is minus 2 times 1 minus 2. So the correct answer here is A. For that first question, none of the above. But here, answer is A. Now let's see number 3. So number 3. Number 3. If log base root x, log base root s 64, that is log 64 base root s is equal to 3. Find the value of x. So to find x here, we already know this rule. Remember, log s to base y is equals to m. If you have this rule, then anything you have here, s, will be equals to anything you have here, y. We carry this one as power raised to power m. So if you apply the same rule here, this will be 64 will be equals to, that is anything you have here, will be equals to root s, that is anything you have here, will be raised to power 3, like that. So if you apply that rule, so now what is the index form of 64? We can have 8 square, you can have 4 raised to power 3, that is 4 in 3 places. Take note, 64 can be 2 raised to power 6 if you use the LCM format, or 4 raised to power 3, or 8 raised to power 2. So any of this will give you 64. So I'm using 4 raised to power 3. Why? Because the power here is also 3. So that's why I'm choosing 4 raised to power 3. Anyone can work, but I'm choosing the one that will make it fast. So now you will notice now that the power are equal. So since the power are equal, the base will be equal. That means 4 will be equals to root s. Since the power are equal, the base must be equal. So how can you remove the square root? So you have to square both sides. You have to square both sides. So on squaring both sides, this square will go. So that means s is equals to 16, because 4 square is 16. So the correct answer is B. So let's see number 4. Number 4. If 2 raised to power n equals 128, find the value of 2 raised to power n minus 1, 5 raised to power n minus 2. So from here, 2 raised to power n is 128. What is the index form of 128? I told you that if you don't know it before, use this format. So the lowest number is 2. 2 in 28, 64. And in 128, 64. 2 in 64, 32. 2 in 32, 16. 2 in 16, 8. 2 in 8, 4. 2 in 4, 2. 2 in 2, 1. How many 2 is this? 1, 2, 3, 4, 5, 6, 7. That means 2 in 7 places is 128. So 2 raised to power n is equals to 2 raised to power 7. Since the base are equal, n is equals to 7. Now n is 7, but the question says we should evaluate 2 raised to power n minus 1, 5 raised to power n minus 2. So what is now 2 raised to power n minus 1? 2 raised to power 7 minus 1, 5 raised to power 7 minus 2. So this is 2 raised to power 6 5 raised to power 5, like this. So let me show. But see the way they leave their answer. So we'll say you will notice that 2 is out, 5 is out. So now 2 raised to power 6, 5 raised to power 5. Now, how can we deduce these results from this result? Because sometimes you will solve, you will think your answer is not there, whereas your answer is there. So if I look at this now, I can remove 2 out first. If I remove 2 out, this will be 2 raised to power 5 outside, then 5 raised to power 5, because this is power 1. If you take 1 out of the base and add the power, this will go back to 2 raised to power 6. So 5 raised to power 5 is 3125. 2 raised to power 3125 times 32. So this will be 2 brackets. 2 raised to power 5 is 32. 5 raised to power 5 is 3125. So this is 2 times 100,000. So if you times these two together, so this is 2 brackets 10 raised to power 5. So that is the answer. So the correct answer is D. Option D is correct. So I'll continue with number 5 in another video.